Alright guys, let's continue with some rules for differentiation. And let's start with differentiation of a sum. Now let u and v be functions of x. If u is a function of x and v is a function of x, now let y be their sum. Y is the sum of u and v. Now if u receive an increment del u, then v receive an increment del v, and also y receives an increment del y. That's y plus change in y is equal to u plus, that's del u plus v plus del v. That gives del y is equal to u plus del u plus v plus del v minus y. That's minus u plus v. That gives del y is equal to u plus del u plus v plus del v minus u minus v. U and minus v cancel out. V and minus v cancel out. That gives del y is equal to del u plus del v. Now divide all two by the increments of x. Since u is a function of x and v is a function of x, so y is a function of u and v. So that means y is also what? A function of x. So divide all two by del x and by del x. Now you take the limits of this. Take the limits of del y del x at which del x tends to 0, and also the limit of del u del x at which del x tends to 0, and the limit of del v del x at which del x tends to 0. So this gives dy dx, and this gives du dx, and this gives dv dx. Now let's take an example on how to differentiate a function using this method, differentiation of a sum. Let's say we have y is, if y is equal to x squared, let's use 2x raised power 3 plus 7x squared minus 8x plus 9. Now find the derivative coefficient of this function. So that means dy dx, if this is u, v. Now here we have u, v, w. We can just say u, v, w, x. Or let's say u, v, w, z. Now this function, du dx, differentiate this with respect to x. Now how do we differentiate this with respect to x? If we have y is equal to a n raised power n. To find the y dx, in our last video, remember this is a constant a. Y is a function of x, and this x is having a power. We just multiply the power with the base, and we replace the power with 1. That's a n x raised power n minus 1. So the same thing here, if you have to differentiate this, find the derivative coefficient of this with respect to x. Since y is a function of x, so that will be 3 times 2, 6x. Then you raise the power by 1. That's 3 minus 2. 3 minus 1, 2. Plus 2 times 7, 14. X. 2 minus 1, 1. Minus. Differentiate 8x. This is 1. So 1 times 8 is 8. 1 minus 1 is 0. The differential coefficient of a constant is 0. That's because we can only find the rate of change of a variable, not a constant. That's what is 0. That gives 6x squared plus 14x minus x raised by 0 is what? Is 1 minus 8. So that's the derivative coefficient of the function, or derivative of the function. Now, another one, the next one is the differentiation of a product. Also, if u is a function of x and v is also a function of x, let y be their product. If there's an increment in y, increment in u, and increment in v, so that's y plus change in y, or just say y plus the y is equal to u plus the u and v plus the v. That's product. So that gives y plus the y is equal to uv plus u del v plus v del u plus the u del v. So the y is equal to uv plus u del v plus v del u plus the u del v minus y. So that's minus uv. This cancels out. So that gives the y is equal to u del v plus v del u plus the u del v. Now the next thing to do is divide all through by del x. So that's the y del x is equal to u del v del x plus v del u del x plus the u del v del x. Now this way. Now take the limits of this at which del x tends to 0 of the y del x. The limits of this, the limits del x tends to 0 of u del v del x plus the limits at which del x tends to 0 of v del v del x plus the limits del x tends to 0 of the u del v del x. So this goes to the y dx. So the limit of the constant is the constant, that's u. And this goes to what? Dv dx. Then plus this, that's dv dv dx. Now the last limit, the u is taken as 0. This tends to 0. So that's the v del x times 0. That's 0. That's plus 0. So the product with us dy dx is what? U dv dx plus v dv. And that's u dv dx plus v du dx. This should be du dx, du dx. So that's product rule. U dv dx plus v du dx. So it means if we have two functions, product of two functions, take one as a constant, take one as u, the other as v. Take one as a constant, then differentiate the other. The other as a constant, differentiate the first one. Now let's say we have y is equal to x minus 1 and x plus 1. And we have to find the derivative coefficient of the function. Y is the function of x. First derivative coefficient, dy dx. We can actually expand this and we can expand it as x squared. It's same as x squared minus 1. Then at the end, find dy dx, which is what? 2x. But here we want to use the product rule. What is dy dx? From product rule, y is equal to uv. So take u as x minus 1, any one here. Using product rule of sum, you can take u as any function and v as any function. You can take your v as this. So v as x plus 1. So u is a function of x. I can find the u dx. Differentiate the u dx here. That's 1 because it is x. 1. dv dx. That's 1 and this is 0. This is 0. So product rule. dy dx is v. You can say v du dx. The same as saying v du dx plus u dv dx, or you say u dv dx plus v du dx. So what is your u? U is what? X minus 1. So x minus 1. What is the v dx? 1. Plus, what is v? V is x plus 1. So what is the u dx? 1. So that's x minus 1 plus x plus 1. The answer is what? 2x. So that's the differentiation of a sum. So let's continue with the differentiation of a quotient. The differentiation of a quotient. of a quotient. Also, let's say u is a function of x and v is also a function of x, and y be their quotient. If u is a function of x and v is a function of x, let's say y is the quotient u over v. If there's an increment in this receives an increment, this also receives an increment. So that's why the u is equal to u plus del u all over v plus del v. So that gives the y is equal to u plus del u all over v plus del v minus y u over v. That gives the y is equal to v u, or just say uv plus v del u minus uv minus u del v all over v into bracket v plus del v. So this cancel out. So that gives the y is equal to v du minus u dv all over v into bracket v plus del v. Now the next thing, find the rate of change with respect to rate of change of the increment in y to that of x divided by what? Del x, because u is a function of x, v is a function of x, that means y is also what? A function of what? X, since y is a function of u and v. So that's v del u minus u del v all over v plus del v 1 over del x. So that gives del y del x is equal to v del u del x minus u del v del x all over v into bracket v plus del v. So you take the limit at which del x tends to 0 of del y del x is equal to the limit of v del u del x at which del x tends to 0 minus the limit u del v del x tends to 0 all over the limit del x tends to 0 of v into bracket v plus del v. So that gives dy dx. You take it as what? Dy dx. That becomes dy dx. So the rate of change of this. So this becomes v du dx also minus u dv dx all over this v times v is what? Is v squared. So this is the v. Remember we take the u as 0 the other time here. So we take the v here as what? As 0. So that's 0, that's v squared plus 0, that's over v squared. So that implies that if you have to differentiate a quotient, differentiation of a quotient implies this v is here. This is the denominator and this is the what? Numerator. So that becomes numerator, just take your numerator and find the derivative coefficient of your, this is denominator, this is numerator, and this is denominator. So that gives v is here. So that's, take your denominator, then derivative coefficient of your numerator minus u, which is numerator, multiplied by the derivative coefficient of the denominator all over denominator square. That's how to find the derivative coefficient of the constant. Now, an example on that, if y is equal to 2x raised to 3 minus 4x all over x square minus 1. Find dy dx. So here, take note of this. Your numerator should be taken as what? As u. While the denominator should be taken as what? As v. So let u be 2x cubed minus 4x, and v is what? X squared minus 1. Use a function of x. That means I can find the u dx as 3 times 2, 6. 6x raised to power 2 minus, that's 4. Because when you differentiate x, that's 1. So the v dx also, that's 2 times x, 2x. 2 minus 1, 1. Minus 0. So quotient rule. That's the quotient rule. V du dx minus u dv dx all over what? All over v squared. V is x squared minus 1. Du dx is 6x squared minus 4. Minus u is 2x raised by 3 minus 4x. Then the v dx is what? 2x over v squared. That's x squared minus 1 all squared. So that gives 6x raised by 4 minus 4x squared minus 6x squared plus 4 minus 4x raised by 5 plus 8x squared, then over x squared minus 1 all squared. So this gives minus 10. That's 6x raised by 4 minus 4x raised by 5. This is minus 10 plus 2x minus 10 plus 8. That's minus 2x squared over x squared minus 1 all squared. So that's using the method of using the quotient rule. That's the quotient rule method. Also, we have the function of a function. Function of a function. Now, what does this function of a function implies? Now, let me use a trigonometric function to throw a light on that. Let's consider this sine square x. Now, this sine square x here, that means it's the same thing as having sine x times sine x. Now, this sine square x is a function of sine x, while sine x itself is a function of x. Look at this, sine square root x. That's the same thing as sine root x times sine root x. Now, this sine square root x is a function of sine root x, while sine root x itself is a function of what? Of root x. That's the function of a function. Let's say we have y, which is equal to x squared minus 1 raised to power 6. And we have to find dy dx here. Now, instead of expanding this, I can actually expand this using binomial expansion of Pascal triangle, then find the derivative coefficients. But to save my time, how do I find dy dx here? I can make u to be x squared minus 1. If I make u to be x squared minus 1, that means the original function becomes y is equal to u raised to power 6. This is u. Then y becomes u raised to power 6. And here, u is a function of x. The u dx is possible, which is what? 2x. But here, y is a function of u. The u is also possible, which is what? 6u raised to power 5. But here, to find what? Dy dx. Now, what if I take this dy dx as dy du dot du dx? Because I can still cancel out this du and the u. That becomes what? Dy dx. So that means this dy dx is what? Dy du 6u raised to power 5 times du dx 2x, which is what? 12x u raised to power what? 5. But remember, my u is what? X squared minus 1 is power what? Is power 6. That's function of a function. Now, it's also called, this particular function is also called, this particular rule is also called the chain rule. The chain rule. Now, look at this function. This is a simpler method. X squared minus 1 raised power 6. You want to differentiate this function. Now, remember, if you have y is equal to x, 2x raised power 2, and you want to differentiate, you take it as 4. Let me use y is equal to 2x raised power 5 or 4. Differentiate this, that's 4 times 2, 8x, remove 1, 3. Now the same thing, if you want to differentiate this one, that will be dy dx, bring the power 6, differentiate this 2x, take this again, everything again, x squared minus 1, then remove 1. As you remove 1 here, that's 5, which is what? 12x, x squared minus 1 raised power 5. So raised power 5. That's a mistake. Raised power what? 5. Because it is u raised power 5. So the same thing. Now the last one is how to differentiate implicit function and successive differentiation. Differentiation of an implicit function. What are implicit function? When y is not expressed directly in terms of x, that kind of function is called an implicit function. All these functions are called explicit function. Y is expressed directly in terms of x. Y is expressed directly in terms of x, that's explicit. But when y is not expressed directly in terms of x, let's say y is also expressed in terms of y, that kind of function is called what? Implicit function. Now, how do we differentiate an implicit function? Let's say we have this, find dy dx if x squared minus y squared plus 3x is equal to 5y, and find the slope of the tangent to the curve, the slope of the tangent to the curve, x squared plus xy plus y squared is equal to 4 at the point 2, minus 2. Now, how do we find the y dx of this? This is x squared minus y squared plus 3x is equal to 5y. Quite different from y is equal to x squared minus 1 or y is equal to 2x raised to power 4. Now, this is the first one now. X squared minus y squared plus 3x is equal to 5y. So how do you find the derivative coefficient? The y dx, that means you have to differentiate this with respect to x, differentiate this with respect to x, differentiate this with respect to x, and differentiate this with respect to x. So how do you differentiate this with respect to x? X squared, that's 2x. Minus, now this is y squared. But we have to differentiate with respect to x. That's implicit. Implicit differentiation. But you have to differentiate this with respect to x. Now this is y squared. If you differentiate y squared with respect to y, that gives what? 2y. But you need to put the recognition that you have to differentiate with respect to x. Now the recognition is what? Dy dx. So you put dy dx plus 3 is equal to, now this is 5. When you differentiate y, 5y with respect to y, that's 5. But put the recognition dy dx. So that gives, but we need to find this dy dx. So that's minus 2y dy dx minus 5 dy dx is equal to minus 3 minus 2x. When you take this one to the other side. So that means dy dx, that's minus 2y minus 5 is equal to minus 3 plus 2x. So this negative is here. We can take it as dy dx. Oh, it should be at the back. It should be minus 2y minus 5 dy dx. It should be this way. So there's negative here, which is the same thing as minus 2y plus 5 dy dx is equal to minus 3 plus 2x. So that gives That gives dy dx is equal to negative dx cancel out. That gives 3 plus 2x all over 2y plus 5. And the next one is find the slope. What does slope mean? Slope is the same thing as dy dx. Find the slope of the tangent to the curve. The slope of the tangent to the curve, x squared plus xy plus y squared is equal to 4. So also differentiate this. When we differentiate x squared, differentiate xy, differentiate y squared, and differentiate 4. So if you differentiate x squared, that's 2x. Differentiate xy with respect to x. Now this is implicit function, and it's even what a product of two functions, function x and function y. So product of two functions. Product rule: u dv dx plus v du dx. You take one, hold one as a constant, differentiate this. Hold this as a constant, differentiate this. So if you hold x as a constant and you differentiate y with respect to y, you get 1. But you need to put a recognition dy dx. Plus, you hold y, you differentiate x, 1. Again, hold x, differentiate y, 1. A recognition dy dx, implicit. Plus, hold y, differentiate x, that's 1. Plus, 2y, recognition dy dx. Plus, this is what? A constant is 0. So that's dy, that's x plus 2y dy dx is equal to minus y minus 2x. That means dy dx is equal to minus y minus 2x all over x plus 2y. Now we have to find the slope, that's dy dx, to the entire to the curve at the point 2, minus 2. At the point 2, minus 2, dy dx at the point 2, minus 2. That means x is 2 and y is minus 2. X is 2 and y is minus 2. X is 2 over y is minus 2. X is 2, y is minus 2. That's 2. So that's 2 minus 4 all over 2 minus 4. That's 2x plus x plus y, x plus 2y, y minus 2x, that's minus, y is what? Minus 2. Minus 2, x is what? 2. So that's 2 minus 4 all over 2 minus 4. So 2 minus 4 over 2 minus 4 is what? 0. So that's minus 2x minus plus y and x over 2y. And the value of x is taken as 2 and y is taken as minus 2. So minus 2, that's 2 minus 4 all over 2 minus 4. So 2 minus 4 is not 0. 2 minus 4 is minus 2 all over 2 minus 4 is what? Minus 2. So the answer is what? 1. So that means that this function is having a curve. This is dy dx. Remember, dy dx is the slope. That means tan theta is 1. That's dy dx, which is the slope of the curve. So that means it's having an angle of what? Of 45 degree. It's having an angle of what? Of 45 degree. That's minus 2 over minus 2 is what? Is 1. Now the last one is the successive differentiation. Successive differentiation. What does successive differentiation implies? Successive differentiation. Successive differentiation. Let's say we have a function y is equal to 7s raised to power 9. If you have to find the successive differentiation of this function, that means you have to find that function in which you can no longer differentiate the function. So the successive differentiation is dy dx, which is equal to Let me use a simple number. Okay, now let me use a simple number. Let me use 2. That's 18x raised power, is even 2 big. Let's use 4x raised power 3. Okay, so divide the x, that's 12x squared. Differentiate again the 2y over the x squared, second derivative coefficient, that's 24x. Differentiate again the 3y over the x raised power 3, that's 24. So this is the successive differentiation of the function. Because if you differentiate this function again, the fourth derivative coefficient, you get what? 0. So the successive differentiation of the function is this. That function you get that you can no longer what? Differentiate, but you get what? 0. Thank you for watching.